The first uses of animal sera were actually back in the late 1800s. And the first large-scale use was in the production of the Salk vaccine in the 1940s, which means this stuff's been around for a very long time. Now, do not be confused. Just because it's been around for a very long time does not mean it's simple. And we'll go through some stuff later today that I think you'll probably begin to understand that. But it has a very long history of use in vaccines and increasingly in monoclonal antibodies and other biotherapeutics. And it's never yet been shown to cause a health-related problem in a person, ever. So I think that's one thing you need to put in context. When you hear the sky is falling, it's actually still up there. And we kind of work to keep it there, frankly, at the moment. I think the thing that everybody loves about fetal and other related sera is they're just so easy to use. You feed your cells some serum, and most of the time they just grow. You don't have to acclimatize them. You don't have to do any of that kind of stuff. And so when you go back in history, it used to be you could publish a paper because you managed to grow a specific kind of cell. And you look at the kind of work that people are doing now and how that has evolved, and a lot of that came off the back of being able to grow cells very easily by using serum. So I think there's that. When you go back in history also, you have a totally uncontrolled situation. Gibco was actually started in a farm in Grand Island, New York, and there was a barn and some cows out the back. And somebody had the idea we could get some money out of these cows by doing this. There were no controls, there were no rules, there were no tests, there was no nothing. You just kind of went out and caught your cow, bled it a bit, and threw it in on your cells and made sure that, look, they're growing, that's really cool. So I think there's when you put it in the context of history and you think how very rudimentary it was to start with, and as you move forward in time, I think the message I hope you get out of what we're talking about today is there is still an enormous amount of innovation going on in terms of managing serum, in terms of the control of the processes, in terms of the kinds of testing that are now possible, all of which is directed towards mitigating risk to the end user and hence, in many instances, to a potential patient. So hopefully that will give us a direction to think in as we go forward.
Yeah. So on the human side, human serum albumin and AB plasma or AB serum were used for years, actually for decades. People were trying to find an alternative to fetal bovine serum. And let me be the first to say, I was at MD Anderson for 10 years, and one of my primary jobs at the bench was to help screen for optimal fetal bovine serum lots. All of the departments, research departments for the entire MD Anderson complex would get together. They would buy every available lot of fetal bovine serum they could get their hands on worldwide, divvy them up amongst all the grad students, research, postdocs, and other various and sundry other slaves that were at the bench. You picked your 3 favorite cell lines and made sure everybody's cell lines weren't overlapping, and we did very rigorous growth curves. And out of that, all that giant amount of data, which usually took months to generate, we would then review every single lot. And from a given company, we would get multiple lots, okay? And from every single company, and there would be hundreds at times, and pick the top 2 or 3. And then every investigator would take a chunk of money out of his R01 or whatever grant he had and contribute to the purchase of the entire worldwide lot of a given set of fetal bovine serum. And that would be our supply for the next 3 to 6 years. So everybody was assured of consistent results across the board within the institution.
And every company in the industry was tearing their hair out wondering what they were doing.
Right. So everybody else's stuff got parked and not bought because everybody would have their favorite child that they would purchase and own. And that's the reality we've lived in and still live in to varying degrees in research. More recently, and part of it, my understanding, being relatively new to this area of the human supplement piece, and I worked at another privately held company on a cell therapy that's in clinical trials, was we were counseled pretty vigorously by the FDA. Sure would like it if you get away from fetal bovine serum, if you can. You can go to, ideally, a fully defined medium, but if not, a human supplement. Now, we spent at my other company millions of dollars in years of time defining a very, very, very expensive and difficult at times to source in terms of growth factors that had to be added back in, fully defined media that still is suboptimal. By that meaning that you get a certain number of passages of your lineage-committed progenitors, and then they start to differentiate. They go the wrong way on you. So even within fully defined media, there's some limitations. Having said that, it works. We've used it. So there's different settings for fetal bovine serum, fully defined media, and for the other product that we've worked on at St. Agatha Blood Bank, which is platelet lysate. The idea there, simple-mindedly, came from 2 points. Will Davey was the one who came up with the idea at St. Agatha Blood Bank. He says, we're tossing these platelets in the garbage after 5 days. They have a shelf life of 5 days, and then if they haven't been transfused, we discard them. So we said, let's pop them open. Other guys are doing it. Pop them open, take the goodies that are inside, because platelets are basically biological Twinkies, but they're a highly controlled, very elegant source of biological Twinkie, if you will. When you think about it, when you have a wound or a vascular insult, one of the first things that happens is platelets traffic to the site and they plug the hole. Well, that's part of their job, but you have thousands of fold more platelets than you need to plug holes. Well, why might that be? Well, your vasculature and your homeostatic systems are constantly needing repair, maintenance, and upkeep. Platelets, because of the content of the platelets, when they're released at a site of injury, they release a very local, regional, very potent set of growth factors that modulate growth, cell recruitment, growth remodeling, and eventually tissue regeneration and healing at that local site. It's one of the most beautiful biological processes as a nerd scientist for me to ever see. You cut yourself, and a couple of weeks later it's gone. If we had to develop the technology to do that, come back in 20 years. We already do it, and platelets are an integral part of that. So simple-mindedly, we said, well, part of regenerative medicine is to grow cells, proliferate them in vitro and ex vivo, ultimately to use in the clinic. And using a human product on human cells, not only does it make the FDA feel better, honestly, if you're doing clinical work, the question it poses for me as a scientist is that one step, it's not totally biologically equivalent, but is it one step closer to the biological milieu that these cells evolutionarily were designed to grow in and be in, And things like epigenetics, things like morphology and functionality, are they or are they not better maintained with the typical substrate that a regenerative tissue would use in the body to do its job? So we've made this lysate, and we've done it a little bit different than most folks have. Most folks generate pretty good stuff, but what they do is they go to all the hospitals and say, take your expired platelets, freeze them down, ship them to us, we'll thaw them out, we'll spin the gunk out, we'll filter sterilize it, put it in a bottle, and sell it as a media supplement. It works. To varying degrees, it works. Right now, across the community, though, the human platelet lysate offerings are pretty heterogeneous. Well, they're way heterogeneous, I'll be honest with you on that. We've looked at different lots from different groups. We've taken a much more systematic approach to optimize the manufacturing process. In the process of doing that, we stumbled across a key finding that really impacts potency. Can't tell you about it right now. We filed patents on it. Sorry. And David's been all over me about that. So we compared it to other platelet lysates that work pretty darn good, and to fetal bovine serum, which works really good as well. And this stuff does some things that's a little bit different, which is why we got kind of excited about it and talked to David about it as well. We think the optimization work we did actually may be biologically a bit more relevant to what the cells need to grow and proliferate before they differentiate. Okay? And we've done things like CD34 cells. We've done, from cord blood, we've done bone marrow-derived T-cell progenitors, lineage-committed progenitors. We've done dermal fibroblasts, primary explants. We've done primary mesenchymal stem cells. And not just us, but we sent the stuff out to academics and other entities to evaluate, blinded, without any bias from us. And the data set shows, primarily, as David mentioned, extremely good lot-to-lot consistency. And some of the issues that come up, though, are we going to have enough platelets to do it? Supply concerns have been a real issue for us. And the heterogeneity across the community as to how they make the platelet lysate has been a concern. We want to standardize that, and that's part of the reason that we're here with David talking to you about it, is that we've developed a product that we think is very consistent lot to lot and will work better as time goes on. Okay, animal.
Are you calling me an animal?
No.
Wait till you see the last slide, and then you can imagine my response to it initially. I think the thing that we have from a standpoint of animal sera and fetal bovine serum is the fact that it is broadly available. There are preferred geographies in the world that people like to get it from. Everybody wants New Zealand. New Zealand accounts for 5% of the world's entire supply of fetal bovine serum, so you can't all have New Zealand. Australia is also very much in demand. That's probably sometime 15 to 20% of what's available. And the US now is 30-ish%. So if you look at the amount of fetal bovine serum that's available on a worldwide basis, the sera of demand are only a proportion of what's out there. It is worthwhile probably observing one of the concerns that people have had with US serum since the US became BSE risk negligible is the fact that cattle come up from Mexico, and Mexico is not risk negligible. I was with the US Department of Agriculture all day yesterday, and believe it or not, no intact female cows are ever moved into the USA unless they are premier breeding stock, in which case you spent so much money on them, they ain't going to be dead anytime soon. So I think what we've got is a situation where we can clarify that now. I've been trying to do that for a while. But you still have a situation where you've got a lot of suppliers and you've got a lot of sources. And depending on your application and the risk you're prepared to take, you're going to pick from one geography or another geography or one supplier or another supplier, depending on how you want to manage what you're doing. And the point that you made, although I'm sure you drove every company in the country nuts.
We did.
Yes. Is that you have to test. The only way you can do this is to test it and figure out what's really going to work. The nice thing about fetal bovine serum is you throw your cells in it and they grow. One of the things that I have been working on recently is there's a grant from the Bill Gates Foundation that is using fetal bovine serum to generate a new polio vaccine. The reason is very simple. The reason they're using that, and you've already alluded to it, it's quick. They have a 2-year deadline to get this vaccine done for use in developing countries. You can't spend millions of dollars and years and years and years developing an alternative if you've got a real tight timeline. I think the thing that a lot of people don't know is how much time and effort historically has been spent trying to come up with replacements for fetal. And yes, you can in fact sometimes do that, but you also can deal with a situation that you alluded to. Your yield isn't what it used to be, the potency isn't what it used to be, and so there's always this kind of trade-off. The nice thing is that every regulatory body in the world says, please don't use fetal unless you have to. And,
Exactly.
and there's still a lot of people who find they have to, and particularly with new and emerging technologies that don't use immortalized cells, you have to use a serum of some sort or another, and it's just a question of which one you pick as far as that's concerned. One of the things that we've talked about is sometimes these alternatives are very, very expensive. Sometimes it takes you forever to get to that point. We were talking earlier this morning, one of the major biopharma companies invested millions and millions trying to go to plant-derived materials, and then discovered there were more unknowns with plant-derived materials. Plus, they were also getting animal-derived viruses in their plant-derived materials. Think about what people spread on fields. Mm-hmm. Think about storage of grain with little mice running in and out. You've got a whole set of different unknowns when you go down that route. And people have found out the hard way that they were actually more questions than there were answers. So I think that's one of the things that you really need to look at. I think one of the things that I could talk about for probably several hours is some of the programs that we put in place to begin to much better characterize serum. Where does it come from? What kind of animal did it come from? do you actually know that what you said you were going to buy is what you actually bought? And we've put programs in place at this point in time to address all of those issues. We have an audit program that takes every step of the manufacturing process and looks at every link in the chain and says, yes, this is what we started with, it went here, yes, this is what we ended up with, and it's contiguous the whole way down. We have just signed a deal on a technology that uses the detection of trace elements to determine where in the world something comes from. So we can tell you, looking at this data, yes, it really was New Zealand. We can tell you it was the US, or Mexico, or Brazil. I haven't got Uruguay yet, but that's the one I want next.
You want to do a site visit.
I got my first Uruguayan member just yesterday, so maybe we'll do that.
What are those sensible trace elements?
Well, it's an analysis that looks at 33 different trace elements, and then there's a very complicated algorithm, which is why we're contracting with another company to do this, that then analyzes the data, and it's really beautiful. We've got 500, I think, samples tested now, and it's really quite clear where the separations are. And that's really important because, you know, if you're buying New Zealand because you want to really minimize the risk to your end user, you want to make sure that you got what you paid for. And this is going to be a way that you can absolutely do that. The other thing that we're working on, and got really good data yesterday, it's very early, but it looks as though we can now tell the difference between fetal bovine serum and calf serum. We've started to get some markers identified that will let us make that kind of segregation. So when you think about where serum used to be, and you think about all the process controls that are now in place, and you think about how we're starting to evolve the testing, the fact of life is, and we were laughing earlier, I was personally told more than 50 years ago that fetal bovine serum was going away. It's not. There's going to be uses for this material, I think, probably forever. And so if you have to live with it, you need to live with it properly. And so how can we provide the most information and the best characterization to make sure that when you do have to use it, it's as safe as it can possibly be? And that's really what it's all about, as far as I'm concerned. The other thing that's mentioned on here is gamma sterilization, and we are in the middle of a set of publications which we are, as an association, we're kind of making a bunch of people collaborate on, is probably the best way to put it, that deal with all the different aspects of gamma irradiation. So we've always said gamma irradiation is the best method of choice for serum. We know it doesn't kill everything. It kills everything except very small unenveloped viruses. But a lot of people have had very weird understandings of what gamma irradiation was all about. I've had people say to me, well, all the big companies have their own gamma irradiation facilities. No. That is a very, very regulated industry, and nobody in our industry would want to get near it. So what we're doing is we're developing articles on what happens when you irradiate in terms of virus reduction. We have a paper on how do you validate dose mapping and configurations for gamma irradiation. We have a paper on cold chain management the whole way through the chain. So there's a lot of work going on to really define how you do that and what kind of results you should expect and how you manage that. So again, it's directed towards helping people understand how to manage risk. So there's a lot going on to really try and clarify a lot of those issues.
So going through the topics, I guess it's the good news and the bad news is the good news is the human platelet lysate products are broadly available with multiple suppliers and manufacturers. The bad news is it's broadly available with multiple suppliers. By that meaning, there is still some heterogeneity across the manufacturing community as to what they're defining as their human platelet lysate. And we actually had a subcommittee meeting at ISCT 2 years ago saying, can we all agree to play together somewhat similarly in the same sandbox? Everybody nodded yes and went back to doing what they're doing. Okay, so that's the bottom line on that. But eventually, at least standardization of potency assessments and C of A's is in process for this because it's a relatively newer field, and fetal bovine serum is a supplement. It can be considered a more defined media supplement in terms of that it's from a platelet. It's the content of a platelet, but it's not a defined media like a true artificial media, which is a totally different beast altogether and far more expensive to optimize and to generate if you're doing it on your own for your own specific cell line. We've avoided the single donor approach because, first off, the volumes aren't there. So we use pool donors, and the benefit you get with pooling of your donors is that you standardize the potency of your product. Because one donor's, there's a lot of papers published on platelet potency or platelet effects in terms of growth factors, in terms of mitogenic signals, in terms of other functional assays, and that the platelets from patient A may have this level of behavior or potency, and the platelets from patient B may have this level of activity. And the way you mitigate the variability is you pool multiple people. Like we use a pooling strategy right now of approximately 15 to 25 to 30 donors per manufacturing unit, and that's variable right now, but we've standardized it to about 24 per manufacturing run. We'll go to larger runs as needed. By doing that, and by managing and normalizing total protein and platelet equivalent concentrations, that's why we've done lots that were manufactured 6 to 12 months apart in separate campaigns, and the coefficient of variance in terms of the performance of them is within operator error who actually ran the cell-based assays. And we didn't show that. We showed it once. I didn't believe it, so I made him show it twice to our team, and then I said, let's ship it to another company that does this and see what they get. And they got even better than the results than we did for lot-to-lot consistency. So we stay away from single donor unless there's a custom use that someone needs it for from a specific platelet function. Routinely what we're seeing is that potency seems to be better at the lower concentrations. In other words, whereas I would need roughly, I can get this roughly the same potency in terms of mitogenic activity for a 2% our product at 2% versus fetal bovine serum at 10%. And it's, that's within the constrained numbers of cell lines. We've only done like mesenchymal stem cells, hematopoietic stem cells, some 8549 lung cancer cancer cells as well. But it looks like it has a lower, roughly a 5-fold lower equivalency in terms of mitogenic potential with the fetal bovine serum lots we tested from ATCC, which are certified. I don't know if that means they're good or bad. You'll have more information than me on that. But buy this to grow your cell. When you buy the cells, we bought primary cultures. They give you the whole kit for an arm and a leg and say this is the super deluxe fetal bovine serum you should use to grow the cells. So that was our comparator versus me going out and buying some grunt grade stuff and trying it out. It works well for persnickety cell lines. They call them sensitive. I mean, a lot of the stuff you're doing is primary culture. They're not immortalized cells per se. Although if you get pluripotent stem cells, you can grow them quite a bit before. And in terms of safety, these platelets were intended to be transfused into patients who were at times severely immunocompromised cancer patients that have a negligible immune system functionality to save their life because they're severely thrombocytopenic. So from that standpoint, from a CGMP, a medical compliance standpoint, it's a safe product. In addition to that, after we get the material to make the platelet lysate, we retest it for IDM for additional pathogens, both nucleic acid-based testing as well as antibody-based testing, and we do a filter sterilization step, all under CGMP. So, if anything, the platelet lysate may be slightly safer than the actual platelets we infuse, but at least the levels of rigor we've applied to this CGMP process assure the safety of the product.
So endonuclease and reduction DNA, all that is.
Yeah, we do. Yeah, we do. Let me be sure before I say endonuclease. But yeah, I believe we do that. And I'll have to check. I'll have to follow up on that. If I don't know the answer, I'm going to say I don't know for sure. I've got all the data. But we have a C of A. We have a C of A, and we have an information set for it that has a laundry list of all of the different tests we do. We even do endotoxin because I'm really sensitive to endotoxin. Yeah. it's the evil, dirty little secret that a lot of folks haven't paid attention to in the context of, yeah, gross levels of endotoxin are bad. Femtomolar amounts of endotoxin, when they bind to a protein, which then is uptaken by the cell, are maybe even worse in terms of the effect they can have on cells. So we monitor all that very carefully as well. Next slide.
Challenges. Fetal bovine serum, other sera are biological. You were talking about 24 per lot. For the most people, when they manufacture serum, they're manufacturing about 2,000 liters at a time. That's probably derived from 4,000 animals. So the problem that you have is if there's one animal in there that has some level of infectious event, you then have 2,000 liters that has the potential to have that. So you've got a lot of difference in terms of the different size, the different stage. We're actually looking at that a lot now too, to make lot-to-lot consistency not something that's totally easy. Let's put it that way. And many people, we were talking before, you do an experiment here, you do an experiment here. There's not a lot of variable except for your serum, but you get a slightly different answer. And that is a recognized fact. And how we're going to deal with that going forward is something that's still very up in the air. Traceability historically has been something that has been an issue. I don't know if anybody here ran into the issue with PAA, but it has been definitely something that has been a bane in the history of the industry. We instituted our traceability certification program in the late 2000s, and we now have 70% of everybody who's been a member for more than 2 years is now traceability certified. That means they've been independently audited to an approved checklist, with an approved audit plan by an approved auditor. So we try to take care of making sure that that's done as well as possible. It's a paper trail because that's what you can do right now. But we hope to add the geographic origin testing onto that so that you've not only got, we know the paper was right all the way through, but you actually, if you started out, you thought you started out with New Zealand, you really did. And gosh, you got it at the end as well. So that's one thing that we're looking at. And so we're pushing very hard to continue to build that traceability certification program because we think it's very important. It is, because it's a biological, it is not defined. And quite honestly, there have been various attempts made over the years. Do you remember the high clone?
Oh boy.
Well, yeah. I mean, they tried to test everything. And there was really no way you could tell what it actually meant, but it looked really good and it was a good marketing ploy. And I
we
think,
got suckered into it in Anderson for a while.
Yeah.
I'll admit it. Yeah.
It looked like they were really doing a nice job, but it's difficult to really define this, and that is something that is consistent. The other thing, and everybody has this issue, is pricing. Not too many people really truly understand that the drought in California had a huge effect on the price of fetal bovine serum. Weather is one of the biggest impacts on pricing because when you have a drought and the farmer can't feed his cattle, he sends them to slaughter. And as he sends them to slaughter, the availability of fetal bovine serum declines. Fetal bovine serum is a byproduct of the meat industry. Cattle come to slaughter pregnant. We don't know how many on any given day. People think, well, don't you plan that? No, we don't plan that. We just catch what comes. So you've got this issue where if there's a drought, the cattle are killed, the supply goes down, and then it takes a long time. Like right now, they're in herd rebuilding all over the U.S. It takes a long time for that to come back up. Now, the good news is that very rarely are all the important places in the world having a drought at the same time. So, but that goes to this last point, consistent. You can almost always get fetal bovine serum, but there will be times when you've been using US and all of a sudden the best you can find is Australian, or the best you can find is something that is not what you've been using. So you can get the material, it will be good material, but it might not be from the same geography that you had it from before. And it all comes down to what's the health of the farming community. And I can't fix that. So
Well, we have our own variables. Obviously, we depend on donors
yes.
for the donation of platelets. These are not compensated individuals. Also, the platelet lysate is a byproduct, if you will, of expired platelets. I guess the, in quotes, good side, as a blood banker, as head of blood bank, it's not that good for me because we're always critically short on platelets. Having said that, anywhere from 12 to 20% of all the platelet units we collect don't make it into the clinic in time because we have a clock of 5 days expiration. And anything beyond 5 days is classified as waste and it gets converted to platelet lysate. So we're always going to have a significant fraction of our product that will be available for platelet lysate. There's just no way around that. So I guess it's a good thing, or, you know, we were handed a lemon and we made lemonade from it, if you will. The consistency is another challenge, as I've said repeatedly now, across the community that generates platelet lysate products. There's been no consensus as to what it should be defined as, and we don't claim that we're like everybody else. We know we're not. We know we're not because we've done our own homework and detective work on what other folks are doing, and we are quite different. But our stuff is far more consistent and far more potent, we believe. Large supply. We've already started mapping that out. What are going to be the logistics if there is a large demand for the material? If that does occur, you know, David Wellis has actually reached out. We're part of the Blood Centers of America network to all of the other blood banks, and they're not doing this. We are, and talk to them about, you know, a supply chain, and it looks like it's quite implementable. So we think that, you know, we should be able to have an acceptable supply. Will it be a huge supply? No, because it's human platelets. Okay, that's just the nature of the beast itself. So, you know, as much as we'd like to say everybody in the world should use nothing but platelet lysate going forward, and we would put you out of business, that's not going to ever happen. Okay, that's not going to happen. But for certain types of things you want to do,
Yes.
having it is going to be important. A lot of companies use additives in their platelet lysate to stabilize it. One of the favorite additives is heparin. Keeps it from gumming up. All right, raise your hand if you know what else heparin does. It's not a good thing in terms of mitogenesis. Who knows? Okay? It's a very potent binding and sequestration agent for growth factors. Most of the FGF families and some of the VEGF subfamilies, and now probably some of the PDGF isoforms, can bind to heparin with fairly high affinity, and that impacts their potency. So when you add heparin, especially heparin that's not well characterized, it's heterogeneous, because it is. It varies from 5,000 to 20,000 molecular weight. So a 5,000 molecular weight heparinoid is an antagonist of basic FGF mitogenesis. A 15,000 molecular weight heparinoid is an agonist. So depending on the lot of heparin you've used and salted into your platelet lysate as a stabilizing agent, you can increase variability and you can affect variability in potency from manufacturing campaign to manufacturing campaign every time you use a different lot of heparin or stabilizing agent. Sorry, I worked on heparinoids as growth factor agonists and antagonists with a guy named Judah Folkman before most of y'all were born. So I go, oh my God, you're adding heparin? Are you defining it before you add it as a stabilizer? Nope. Just using the stuff that comes in the bottle and throwing it in. Okay. So, we don't have heparin in our stuff. No additives. You know, NGO, no, I guess we could do a marketing pitch on that, but we don't. But we don't add heparin, you know. GMO, you know, none of that stuff. Well, other than the fact that we're humans. We don't have that stuff in there. And the reason, and I adamantly opposed it because we were having that conversation saying, why don't we add heparin? Everybody else does it. I said, here's why. So I wrote them a book chapter on it, and they walked away after that. Cell yield and cell function. I mean, the overall intent here for both of us is to improve the quality and consistency of the science that we do. I mean, at the end of the day, we live and die. It's nice to do in silico work. At the end of the day, somebody's got to take a cell and do something with it, and then take that cell and make it do something else, or affect that cell with a therapeutic, or in this case, use those cells to heal a human condition. I can assure you that if I take mesenchymal stem cells from a single pot, divide them up into 10 pots, and I take 10 different platelet lysate, or possibly even fetal bovine serum concoctions, and throw them on the cells, and I look carefully, I could see differences between those 10 different lots of cells that makes me think they're 10 different cells of origin, and they're not. So the intent here is to standardize the media supplements that we use to help make better science. Judah Folkman ran into this. I went to lunch with him, and he'd had a couple glasses of wine. He says, man, you can't believe the beating I took when I talked about what that was called the heparin paradox. In other words, he was having heparin spiked into his gamish that he was treating cells with. And in some cases, the heparin caused the endothelial cells not to proliferate, and it had angiostatic or anti-angiogenic effects, which is where his claim to fame was. In other cases, he'd get another lot of heparin, or another investigator at another site would get another lot of heparin and use it, and it said, you're a liar, your stuff stimulates the growth of the cells. Lack of standardization. For almost 10 years, his work was highly controversial and gained no real traction because of lack of standardization of the materials being used to do the assays. You know this. You worked on basic FGF. You know the oligomerization story of Spivak-Kreutzmann and how that matters, okay? Basically, heparin works like beads on a chain. It helps potentiate dimerization of the cell membrane receptors for mitogenesis. If you've got real short heparins, you create monomeric states, no dimerization, inhibition. Growth media supplements can have the same kinds of problems. We're going to fix that to accelerate the science so better cures get there quicker. And also it'll be more fun to work on your cells and knowing that what you find, your colleagues can find and confirm too, versus having to argue with them over beers at the local pub late at night about what you did wrong and what they did right. Okay?
I think one of the things that has happened in the last 10 years since we founded the association is we are doing a lot more science trying to really understand what's going on with some of this stuff. And I see that definitely as continuing to evolve. As I said earlier, we've got our first ever age delineation, but there's lots of other stages. And so once we've got a couple markers going, we're going to be able to dig out and find more and understand what the relevance of that is. I think, the chemical fingerprinting, we're in early stages right now. We can tell, I think it's 7 or 8 different parts of the world. And they're the kind of important ones. They're the ones where most of the stuff comes from. And we can tell them from each other very happily, but there are also going to be other things that we're going to want to do with that. I think there's a whole saga out there in terms of what other kinds of post-manufacturing treatment can you do to continue to further reduce viral risk. And, we may get to a point where we can really actually start to understand what some of the critical components are and how we can maybe help normalize things. One thing that would really help us would be if we did know why people don't buy something. Because we struggle right now with as we were joking, if a company or a lab goes out and they get 3 samples from 3 different manufacturers and they say, I'm going to buy this stuff, you put that lot on hold, and it's 2,000 litres a lot, right? So we've got 9 times 2,000, 18,000 litres of fetal are sitting. It sometimes takes 6 months for somebody to decide which one they want, and then when they buy it, they might buy 2,000 litres. So the other 16,000 litres that have just been sitting there suddenly reappear. And we don't know why. We don't know why they bought that one. So how do we get to a state where we can understand better why this works for that kind of cell and this works for that kind of cell, so we can do more pre-selection, so that we can help you make your decision quicker, so that we don't throw the whole market up in the air, because when company A hears company B sampled for this and we're sampling for it, gosh, there's got to be a lot of demand. So they all run out and try and get more serum and the price goes up. So we have this self-perpetuating volatility in the price that is mostly driven by what's going on in the market, but it's also driven by demand, because if you think you're going to sell stuff, you want to go and get it. So there's some interesting things there. So I think we're going to continue to drive towards more consistency, not just consistency in the serum, but consistency in how it's talked about. one of the things that's been really critical, and this is not a claim to fame by any stretch of the imagination, when we founded the association, it took more than 6 months to get people to agree on a definition of fetal bovine serum, because everybody had their own little story about what it was. And so now what we have is we have definitions. This is what fetal is, and this is what this is, and this is what this is, and please don't misrepresent it, because we're going to come and get you. And I think that and standardization of testing, so that you get results that you can compare, so you can look at material from company A and company B. Now, we'll never get it to look exactly the same, because everybody does their own little marketing thing, and we talked about that too. But I think there's a lot that can be done to streamline and to standardize how data is presented, how information is presented, what information is presented, that we'll be continuing to work on. The ultimate, and this is doable in some geographies but not in others, is knowing exactly where the stuff came from. So if you're in a country that tags animals, you can have a very good idea of exactly where that material came from. Sitting with the USDA yesterday, I mean, one of the things that we were all agreeing is, for some reason, cattlemen really like brands. Mm-hmm. And I mean,
and cowboy hats.
And cowboy hats. And you cannot, I mean, I've sat in meetings when I've been like, what? But it's going to be very hard. Something horrible is going to happen before the US cattle industry will go away from branding cows. So I can tell you that in the US, the traceability from the animal to the bottle will not happen anytime soon, but there are other parts of the world where it does and can. And I think, that's something that's going to be extremely important. I think the other thing, too, is if we could stop the swings in apparent demand in the market, it would be much easier to get to longer-term pricing strategies. I've had one very large company come to me and say, we want a lot of serum, but we don't want to create a demand spike because we know the price will go up. And so we've been working with them to try and facilitate conversations in such a way that they approach the market in a rational fashion and not, make everybody think that it's going to be wonderful, we need to go and get this stuff. So I think there's things that we can do to continue to improve those kinds of situations. And as I said before, the fact of life is that for many applications, you still need fetal and other animal sera. And so we're doing our best to try and make it an easier choice and a more rational choice of what it is that you're actually being provided with.
Absolutely. I mean, I would not, our data set is limited because we haven't tested every cell line in the world. I would never claim that the human platelet lysate variation that we've generated is a panacea for everybody, for everything they want to do in the world with mammalian cell culture. Not at all. It clearly has some utility and some advantages, we believe, and we have data to support that for specific subsets of cells related to regen meds, stem cell therapeutics, and things like that. The other piece that we strive for, both with fetal calf serum and with this product, is what I call what I like to call, and it's my own homemade term, phenotypic fidelity.
Yeah.
As you grow, propagate, expand, and manipulate the cells, you want to make sure that the same stuff that you started with at the beginning as when you end and use it for other things. Otherwise, it's difficult to make correlations, linkages, and identify causalities if you're trying to develop a therapy, a new target, or whatever. So that's still, for us, a relatively unmined area that, I don't have the molecular, so it's just a solicitation for folks. Anybody out here is doing epigenetic studies? We'd like to see what is the impact of our product in terms of maintenance of the primordial or the primary epigenetic phenotype of a cell derived from a primary tissue at time 0 versus at time X after exposure or treatment with various things, whether it be fetal bovine serum or human platelet lysate. Are we maintaining fidelity? From a gross functionality standpoint, that appears to be the case. In the new era of precision medicine and genetics and the genome, dissection of the genome and epigenetic effector systems, having a stable environment that these cells are grown in is going to reduce the the wheat, the chaff, reduce the amount of chaff you have to sort through. How many people here have had to do heat plots? You got a zillion signals that are differential. Look at green versus red heat plots. Would these types of standardized supplements help reduce the signal to noise ratio to make it easier to more rapidly and more with greater confidence and fidelity identify targets or effector pathways that can be considered as part of a biological process for a therapy or just fundamental scientific discovery?
So are you doing the cell work in the lab?
We're not doing the epigenetics piece. We don't have that
Just growing the
ability.
cells and looking
We
at the
do. We
fidelity
just
with
we do. We just the
ISIA.
standard markers, things like
Yeah.
that for
Do you also-
mesenchymal and just gross morphology and stuff.
Do you also look at minimally defined or minimal media, completely defined
We've
media
done.
to compare how that fidelity changes to maybe have
Yeah.
to even position your product above?
Haven't done it yet. We've done serum-free media concoctions, and what happens there is, unfortunately, with supplements we smoke it in terms of proliferation. So we haven't looked at fidelity. And once again, like I said, we're not claiming a panacea, but I think that's a whole area that's ripe for opportunity to better understand. Because once again, I go back as just an old biologist to say, okay, when a cell is growing, the biological Twinkies show up, they release their product, and those cells do their normal thing that they normally need to do to heal, fix, and regenerate. If they don't do it in that normal biological context, what is wrong with that cell? Versus if you throw something artificial like a fully defined median, have you stripped away something to cause a false signal that you might chase? Those are the kinds of things I think about, and the kind of things where I think the utility of fetal bovine serum and a human platelet lysate product can better address or mitigate the risk of a false positive or a false negative. As far as traceability, I had a conversation and I got hit over the head about it. Say, can I microchip all of the O-negs that come through the door? And the answer is no. But we do have a way to trace every individual that donates a platelet unit that goes into the product. We can reach back to and identify who that individual was. And so obviously we do health care questionnaires, we do health screening, we make sure these people are healthy. I won't say normal healthy donors because I'm a donor, but at least they're healthy. Okay. So we have that traceability, and they won't let me microchip people. We can't brand them.
No.
Oh, right here on the side of the head, so we know to chase them down. Yeah. But, stay tuned as far as the future of human platelet lysate formulations. We've got some ideas and some new data. There are some things that can be done to further modify or optimize these things for different specific settings. So it's going to give us more latitude in terms of what the researcher or the cell developer needs in terms of what they want for an outcome. I mean, one of the defaults we get with human platelet lysate, and I haven't figured it out yet because I haven't had the time, is why we can grow the cells far, far longer without any drop-off or depletion. In the human platelet lysate product, we have fetal bovine serum or some of the other human platelet lysate products we've looked at. Looks like just from a cost of goods standpoint, if you're a cell therapy guy, this stuff will require a lower frequency of feeding and a lower absolute concentration of the material, 2% versus 10%. Feeding every 7 to 10 days versus every 3 to 5 days. Is that going to hold across the board? I don't know, but for MSCs from various source types, it appears to hold very nicely, and other cell types. Why is that? Why is that happening? I love that question because that's something we can look at. Is it affecting apoptotic or pro-apoptotic or anti-apoptotic pathways? How relevant is that to the product you're trying to generate for research or for clinical trials? Stuff like that. Anyway, a million things. But so we've been tinkering. We haven't quit. We've got a very, very, very good product that's ready for use. But I'm a scientist, and my crew's a scientist, so we're tinkering. Anyway, I'll shut up.
Can you both speak to how much you do with testing on cells themselves, and what type of information and how critical that is to you?
Most manufacturers will test for cell growth and cloning efficiency. They'll do it on a variety of cell lines. The problem that the industry faces is that if I am big company X and I have genetically engineered a cell line to produce a certain very specific protein, I need to make sure that the fetal bovine serum I buy will work for my cell line, and I will not give my cell line to anybody. So what we can do is we can say, yes, this stuff looks like it works. It looks pretty good. We don't see any inhibition. It works fine for cloning. Try it. And so really that's what has to happen. And that is something that people have been talking about, trying to find ways around that forever, and I don't think there is one.
And how long do you culture the cells?
Oh, it really depends on most people. There's a very well-defined protocol. You can actually now buy a fetal bovine serum standard that you can use to show that you know how to grow cells from the USP, because we worked with them to write 2 chapters on bovine serum and also to generate a standard. And it's the first non-small molecule standard they ever did, and I don't think they'll ever do another one. But that was a hard slog, but we got there. But I think, that part of the problem with some of this stuff, and you know this, it's not, you can follow a protocol, but some people have lead hands.
Boy, do they.
And, just because it says do this, 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 and this, it doesn't, there's an art and there's a finesse to doing some of these things that you just can't write down.
Yep.
And so, we kind of laughed a little bit. They said, well, we want a standard to prove that people can grow cells. And then we thought about it and we said, oh yes, the ones with lead hands. We should do something about this. And so they do have this commercially available. But I think it goes to the fact that a lot of what we're doing, the complexities of the reagents are part of it. But there's also the fact that you've got different people sitting in different places, trying to do the same thing, and it's not going to come out the same way. My favorite story is I transferred a technology to Japan, and it worked really well in the US, and it didn't work at all in Japan. Didn't work at all. So they put me on a plane. They said, go to Japan and find out what's wrong. So I went to Japan, and I'm in the lab, and I'm standing there looking at this kid, and he's a petrochemical engineer doing a microbiological manipulation. And I'm thinking, okay. And then I realized that unlike a sloppy American technician who sloshes the buffer down the side of the tube so it swirls around at the bottom, he was pipetting it absolutely precisely into the bottom of the tube. So the tube was not getting washed. So the inhibitor was being carried over, so nothing was happening. But you had to be there and see it. Yeah. And I think that's what makes this all so interesting, is there's this whole art. You can't call it anything else, can you?
No.
To doing some of this work. And there's always going to be a level of about it because as a result of that. So to answer your question, it really depends on what they're doing. I think for the guys who are really have the very tailored cell lines and are doing a lot of very detailed work on it, they're really understanding what's going on in the growth process. And the kind of technology that I think you have available would be very beneficial to people like that. But to Joe researcher who just wants his cells to grow, he's not going to be looking at a level of detail in most instances unless he's really studying something about the morphology of the cells.
Yeah. So we have a minimal potency release assay we do basically, and the canary and the coal mine we've used is our umbilical cord mesenchymal stem cell. We'll do a 9-day proliferation assay with no feeding. Plate them.
Let them go.
Time points out to 9 days. And that's that combined with our, we also have banked a large amount of reference standard. It's not a formal reference standard from a CMC standpoint, but what we call a reference standard lot of platelet lysate. When it's depleted, we've got enough for a couple of years, but when it's depleted, we'll generate another lot. And we compare any new manufacturing lots to the reference standard. At least we're doing that right now internally. Whether that's going to be part of a formal process and maybe whether additional cell lines would be included as part of a release assessment or not is to be determined. But that's what we do internally right now. To your point, we've tried to de-idiotify our product, and I'm the beta site internally. Okay, give it to
I used to
Tressler,
do that.
you know, see if he can make the cells grow like we can make them grow. And by and large, I tend to be as good as the team that does the real work. I'm not the guy that does the work. This is another crew that's actually a lot smarter and a lot more disciplined than me. But yeah, I'm the beta site for that. And we're trying, because there is an art to this, unfortunately. You know, and you know, at times I've said, "Let me come to your lab, please, and see what you are doing," because I do not understand.
And how are you, Pipette?
Oh well, you know, you've heard of quenching your trypsin before you replate instead of leaving it in the okay. You know, stuff like
Other
that.
questions?
Yeah.
I have a question. What else do you know apart from the antiviral properties of irradiation, how gamma radiation changes fetal mobility?
If it's done properly, you can manage very minimal changes. If you don't, the biggest thing during the irradiation process is to keep it really cold. So it's always done on dry ice. But having said that, some sera react differently than others. There's the paper that we're about to publish on cold chain shows quite clearly that you get all kinds of different forms of interactions between the gamma and the polymers depending on the temperature that you're at. And so I think there's a demand for really understanding and defining. Now the problem is that most gamma irradiation facilities, if you make your specifications too tight, they can't do it. So you can't find anybody to do the irradiation for you. So, you know, mostly it's between 25 and 50 kilograys. If it's configured properly and it's kept as cold as it needs to be, you will get minimal impact.
Interactions in maturation proteins and things. I mean, what's physically?
It's scission of well, what you're looking for is scission of the nucleic acid in the viruses, right? That's what you're looking for. What you get if you don't do it right is you get cross-linking and scission of proteins, and you also get interactions between the container and the contents. And any of those things not quite right can impact. Now, I know somebody who says you can irradiate up to 70 kilograys and the stuff will still grow things. I have a problem personally believing that. I think he must be doing one bottle in a sea of dry ice. But I think, you know, most of the time, and almost, I think all vaccines are now manufactured using gamma irradiated material. So there is a database that says that you can do this in a way that doesn't kill your serum.
Can I ask a question? Do you find variability in the need for gamma depending on the origin of the FBS?
Well, from a regulatory standpoint, the regulations are kind of specific. They give you a range. Most people just simply do the range. The range will, in fact, take care of all the basic bad guys. So BVDV is very, very susceptible. Blue tongue is pretty susceptible. Foot and mouth, actually, although I can't get the U.S. Department of Agriculture to believe it, is very susceptible. So anything that's a large enveloped virus just goes. Anything that's a kind of intermediate size, unenveloped virus, you can hit. The very, very small unenveloped viruses are very resistant. But again, for many instances, you look at, okay, what am I going to do with this? Do I need to ramp up the level of irradiation even higher? Or am I okay because that's not something that's going to have any impact on what I'm doing? And the fact is, and we talked about this back at the office, it is by far the best method of choice at this point. Many of the newer technologies have been tried. High temperature, short time, doesn't work, it cooks the serum. UV doesn't work, it cooks the serum. So they're much more negative in terms of their impact on the material than gamma is at this point in time. Heat inactivation, this is something that is an ancient history thing, unless you are trying to inactivate complement in an adult serum, heat inactivation doesn't do a thing. It's not reproducible. It raises all kinds of questions. It's because it's done on a bottle by bottle basis usually. I do know people who do vats of it, but it really doesn't do what I think people really want it to do, and so that's why we recommend gamma.
To follow on that question is, does the trace element profile have impact on the effectiveness of the gamma radiation?
No, not that I'm aware of at this point in time. But I'm early in that. That's a good question.
Your molar content's probably low enough.
It's really
to where-
low. I mean, you're talking.
I mean, to your point, but I think you've got
Yeah.
it should truly be trace, ppm, lower than sub ppm. Therefore, I would think when you look at just from mass action, the amount of protein there,
Mhm.
that yeah, there could be bad stuff happening, but it's such a small level that it may not be detectable in terms of a biological phenomenon. But it's a good question.
It's a good question. We'll have to check that one out.
So you mentioned ATCC
Mhm.
website. Can you give some comments on that? Are their information reliable? Because most labs believe to rely on their information to culture cells, DMEM, medium, or EMEM, or serum, or FBS. We don't think that they are good information. Most people use their information to culture cells.
That's true. They don't make their own fetal bovine serum. I probably don't know if I should say that, but they don't. So they don't have a great understanding of fetal bovine serum per se. But they have a program where they will say, if you want to grow these cells, you can use this serum, and that will get you started. And that certainly is helpful, I should imagine, to people who are just trying to do something but aren't really prepared to investigate exactly what would happen. There are issues with some of their cell lines, as you know. I mean, they basically say this one's got this mycoplasma often.
Right.
And that's an issue for a lot of people because you don't want to have mycoplasma running around your cell culture lab. And so, that's something that they have gone public with in various ways, and that is an issue for a lot of their cell lines. But, I know a lot of people who work there, and they do a good job in the basics of what they do.
Yeah, ATCC, I think maybe part of it was self-inflicted, but part of it was inherited. They took in cell lines from all over the world to start
Yes.
up the original tissue bank.
Yeah.
And the quality and integrity and the traceability of how those cells were generated and then shipped to them was problematic back in the day.
Mhm.
So whenever I still do this, although my youngsters think, wow, it's from ATCC, it must be good stuff. I'm still like, well, I don't know about that. Let's check it out. Let's be sure. Let's make sure there's no mycoplasma or cooties in this stuff before we release them to the general lab. But yeah, I mean, there was a whole book chapter on the Gila contamination catastrophe that infected ATCC. A dear friend of mine who's now gone, Rel DeCaillou, who actually did a lot of the work in the expose on that. So yeah, great organization. I've lived and died by them, for decades, and will continue to do so.
But ask a question now and
Yeah.
again. Well, and it's a very important issue because one of the things that turns out is when you look at the early products that came through from biotechnology, those master cell banks were not well characterized. They often came out of a research lab somewhere. And I get people calling me going, well, what lot of serum was used to make? And it's like, excuse me, please? But I think there's a much higher level of understanding now of the level of control that's required when you're setting up cell banks and how you manage that and how you make sure that what you've got is really what you think you've got and that it is clean. Because it is a huge issue in terms of carryover and negative effects if it's not. But I know I agree, they provided a great service, but ask a question or two.
This would only be for you.
Yay.
About prions?
Prions?
Yeah.
Oh, okay. First of all, prions don't cross the placental barrier. Second of all, animals are now killed in a way that minimizes the potential for any brain-related material to get into the bloodstream. Third of all, there's an age limit in many places of what you will use material from. Fourth, BSE is actually one of the great successes in the world. The animal feed ban did exactly what it was supposed to do. The incidence of BSE now is vanishingly small. There is periodically a case that appears. They're always currently spontaneous. It's just something that happens. It's not an infection that went from here to here to here. Now, having said that, I'm not allowed to donate blood because I used to eat British beef. But really, it is a wonderful success story in terms of really taking something that was horrendous and bringing it down to essentially noise. I mean, there's very, very little. Now, all the rules, pardon?
It's still extensively monitored, right?
Oh, it's still, I mean, we're still leaping through flaming hoops with regard to making sure that there is no way that things can happen. But the thing of it is, what was done when it was done was absolutely perfect. But now we're living with a legacy of still operating at the level when it was really an issue. And everybody's doing it. I mean, all the same controls are still in place, but they're all in place to try to control something that's already controlled.
Right. And part of the reason why I ask is that in the beef industry, the cattle are slaughtered. They're not allowed to be older animals, but because your stock animals they're older. That's why I asked.
Not necessarily.
Yeah.
Not necessarily. There's occasionally an old cow who comes out of a dairy herd, but an awful lot of the animals that are coming out for slaughter are meat quality,
Yeah, okay.
So it's not,
Yeah.
not everybody lives in a feedlot their whole life. So I think this is something we were talking about the other day. People say, well, why do cows come to slaughter pregnant? Well, they're out in the prairie, and there's a couple of those boys running around with them.
I knew somehow or other guys would be blamed for this.
and so that's how it happens. It's kind of natural. And every so often, the farmer says, "I'm going to sell off all these guys," and off they go. And sure enough, a certain percentage of them are providing fetal bovine serum down the road. So, does that answer your question?
Yes.
Pardon?
Happy cows.
Happy cows. Well,
Any other questions?
that's California cows, isn't it?
Why is it considered New Zealand and Australian serum is the best?
Disease, perception of disease. Neither of those two countries has ever notified for BSE, and that goes back to that one.
But if you said BSE occurs spontaneous.
One cow in, 35 million cows are killed a year in the US. That means there's a whole lot more than 35 million cows running around in the US. There was one spontaneous case 4 years ago. So pardon?
Was that in Washington?
I'm trying to remember. I think it was.
Didn't it come from a Canadian herd?
No, that's the one that got us the risk thing.
Right, sorry.
The spontaneous one just was spontaneous.
Yeah.
It was a Mountie. But the other thing, there are two reasons that people choose the geographies they choose, and this is one of the reasons why US is very popular as well. You can have all kinds of laws, but how well you implement those laws is very important. So when you look at a source, you're looking at the disease profile of the country. You're also looking at the infrastructure that supports that and how well it's regimented. Now, I will share that some years ago, although they've gotten much better, the country of Brazil registered 2,500 slaughter facilities in a week. So nobody believed that at all. And so you've got to look at, Australia, New Zealand, and the US are very rigorous in terms of their enforcement, in terms of their inspections, in terms of all those other kinds of things. Lots of other countries are too, but because of disease as well as infrastructure, they are the preferred sources. That doesn't mean to say that serum from Brazil won't grow your cells perfectly well. In fact, in Europe, almost all research is done with Brazilian serum because it's much less expensive. So again, it comes down to what are you trying to do? What kind of risks are you prepared to take? Brazil has foot and mouth disease. That's the issue with Brazil. And how are you going to make that decision in a way that lets you do the science that you want to do while still taking care of the other issues that you're trying to balance off? And in all these things, there's a balance, We could test serum for everything, but you'd never be able to afford to buy it.
Or there'd be none left. Or there'd be none left.
Or there'd be none left. That's the end of that tag. Yeah, we could test it to death.
I have a question regarding the human medium supplements. You mentioned about the human HSA, human serum albumin. So would you recommend use HSA or human serum culture cells?
Human serum albumin, highly purified forms of it, are limited in terms of nutritional impact. They're thought to play some transporter role for nutrients. You'll need more than that in media. It's basically, we
And the stabilizers take all the binding sites.
exactly.
That's why it doesn't work well.
So, I mean, it's an amphipathic molecule, so, it has some hydrophobic, hydrophilic interactions for transport. And it's thought to play a role in nutrient transport, possibly, cytokine or hormone transport, although that's not been well characterized. But in and of itself is not sufficient. Because if it's a transporter, it means the other stuff needs to be there to be transported in to facilitate proliferation.
Yeah, to me, the HSA is too big for cell. We'd rather take some free amino acid, that may be much easier for cell to digest, right?
Yeah.
So why we give such huge protein to give the cells and intake and digest by cell?
Yeah.
Use lots of ATP.
Right.
But use lots of short peptides or this free amino acid that is much easier,
Right.
like DME.
Yeah, absolutely. For basic, and you have nucleic acid receptor type of systems on the cell surface already. You're designed to pick those things up. But some of the more complex systems, there's been some papers published on it because I looked into this quite a bit. I was thinking, we just get rid of everything that uses HSA in a defined media and solve all our problems. And it does play a role in transport of certain types of cytokines and molecules, complex beasts, the larger complex beasts. For basic nutrients, glucose metabolism and protein metabolism, nah. Other questions? She'll answer them.
Well, I wanted to thank the speakers. I thought it was a great. We wanted to finish.
Beware of the boxing cow.
Rosie said that's not me, is it? But the question we wanted to ask is which will win, and I think what we're hearing is it really depends. It depends on what your needs are. It depends on what your cells are, and we're hopeful that you'll consider us because we're going to actually have both solutions, both an animal source and a human source media supplement. So thank you for coming, and thank you to the speakers.
Well done, thank you.